Hi students, greeting of the day and welcome to this video channel. As per your mails, we have recognized that you require the questions for practice, and what we are doing over here into this parameter is we are making a system where all the 16 chapters of our chemistry subject and the marking scheme which is given by the board, as per that we have sorted out the questions. Just for an example, the first chapter, the solid state, the question which are going to be asked in the board examination as per the blueprint are one question of 1 mark and one question of 2 mark. So as per that, around 5 to 6 questions have been selected by our panel, and those questions are discussed over here. So those questions may help you out with the answers. We are giving you the questions as well as the answers to it so that it becomes easier for you to go for the practice. Just see the question, read the answer, write the answers so that you come across how much of the portion is to be written. Basically, this exercise is done so that it becomes easier for you to write the answers when the questions are there for the boards. So practice them properly. They are mark based, minute based and topic based. That is, this is the homework which we are doing so that at the time of examination or inside the examination hall, you are not in panic. You know that this question is there. What is the weightage? Just for an example, 1 mark counts for 2 minutes and you have to write around 30 words. So that is maximum 30 words you have to write. So your speed when you practice it gives you a confidence for the examination. So students, best of luck for your examinations and practice this question series so that it becomes easier for you to get good score. We require more than 95%, and this is a technique by which you will be in position to get the marks. This is my 29 years of experience where I have worked with the students on this parameter for the examination and have given them good marks. So be prepared with it, and thanks a lot. See what we are dealing with this into the questions and the parameters of the time management. So thanks. So students, as per the marking scheme, we are discussing the questions, and those are very important questions for your parameter. So practice them properly so that it becomes easier for you. Now from the chapter solution, if we see, there are probable questions to be 3, out of which one question will be of 1 mark and 2 questions will be of 2 marks. So we have segregated rather 1 mark question and 2 mark question so that you can practice them. Starting with the 1 mark question, the first question says the molecular mass of polymers are determined by osmotic pressure method and not by measuring other colligative properties. Give 2 reasons. So basically over here students, the answer says that first one is it's measured at room temperature, and second, it has appreciable value. Now over here you are aware of the fact that colligative properties, the rest of the colligative property, that is the elevation in boiling point, the depression in freezing point and the relative lowering of vapor pressure, these 3 concepts, they cannot be applied because the value variation is very small, and henceforth it's difficult for us to calculate the colligative property. So we are using osmotic pressure, as the polymers, they are the large molecules. Coming to the second question, at 300 Kelvin, 36 grams of glucose C6H12O6 present per liter in its solution has an osmotic pressure of 4.98 bar. If the osmotic pressure of another glucose solution is 1.52 bar at the same temperature, calculate the concentration of the other solution. So over here we are taking 2 relations, that is the 2 solutions are there. So pi 1 upon pi 2 is equal to C1 upon C2. Now over here the value of pi 1 is 4.98 and that of pi 2 is 1.52, so that is equal to 36 by 180 upon C2. We have to calculate C2, so it becomes equal to 36 upon 180 into 1.58 upon 4.98. When simplified, it becomes equal to 0.061 moles per liter. Coming to the third question, students, define the terms osmosis and osmotic pressure. Is the osmotic pressure of the solution a colligative property? Explain. So over here, first of all, the first part, osmosis. So when a solution is separated from the solvent by a semi-permeable membrane, which allows the passage of solvent molecules but does not allow solute particles to pass through it, there is net flow of solvent molecules from the solvent to the solution, which is called osmosis. Over here it's one-way migration, that is from one concentration to another concentration through a semi-permeable membrane. Now osmotic pressure is defined as extra pressure that must be applied to the solution side to prevent the flow of solvent into solution through a semi-permeable membrane. Coming to fourth question, calculate the boiling point of solution prepared by adding 15 grams of NaCl to 250 grams of water, where Kb for water is 0.512 Kelvin kg per mole and the molar mass of NaCl is 58.44 grams. Now, over here one thing is very clear, students. Since NaCl is there, it dissociates into Na positive and Cl negative. The value of I becomes equal to 2. So when we take the relation delta Tb is equal to I into Kb into Wb upon Mb into 1000 upon Wa, there delta Tb becomes equal to 2 into 0.512 into 15 upon 58.44 into 100 upon 200, which is equal to 2.0512 into 15 into 4 upon 58.44. When simplified, becomes equal to 61.44 upon 58.44, which is equal to 1.05. So boiling point of solution is 373 plus 1.05, that is equal to 374.05 Kelvin. Coming to 2-mark question. The first question says, it's a direct question, students. So that says, explain Henry's law about dissociation and dissolution of gas in a liquid, and second, boiling point elevation constant for a solvent. Henry's law states that the solubility of the gas in liquid is directly proportional to the pressure of the gas. P is equal to Kh into X, where P is the pressure of the gas, X is the mole fraction of the gas, and Kh is the Henry's law constant. Second part, boiling point elevation constant, that is also known as molar boiling point elevation constant. It is equal to elevation in boiling point of 1 molar solution, that is 1 mole of solute is dissolved in 1 gram of solvent. It is also called ebullioscopic constant. The unit of Kb is Kelvin per mole or degree Celsius per mole or Kelvin kg per mole. Into the sixth questions, a solution of glycerol, that is C3H8O3 in water was prepared by dissolving some glycerol in 500 grams of water. This solution has a boiling point of 100.42 degrees Celsius. What mass of glycerol was dissolved to make this solution? Kb of water is 0.512 Kelvin kg per mole. So for the solution Wb, write one more thing, students. I'll like to make it very clear. Whenever the numericals are there, you just consider it in such a way that you first write what is given to you and what is to be calculated, then the formula, then the substitution, because there are marks for every substitution. So over here Wb is to be calculated. Mb is equal to 36 plus 8 plus 48 as per carbon 12 into 3 plus hydrogen 1 into 8 plus oxygen 16 into 3. So total mass becomes 92 grams per mole. Wa is 500 grams given to us. So delta Tb is equal to 100 minus 0.42 degree Celsius minus 100 degree Celsius. I repeat, delta Tb is equal to 100.42 degree Celsius minus 100 degree Celsius, which is equal to 0.42 degree Celsius. The relation which we are considering is delta Tb is equal to Kb into Wb upon Mb into 1000 upon Wa. So Substituting the value 0.42 is equal to 0.512 into WB upon 92 into 1000 upon 500, or WB becomes equal to 0.42 into 92 upon 2 into 0.512, which is equal to 38.46 upon 1.024. When simplified becomes equal to 37.73 grams. Coming to the seventh numerical, that's the theoretical question. Non-ideal solution exhibit either positive or negative deviation from Raoult's law. What are these deviations and how are they caused? So for the positive deviation of Raoult's law, over here the non-ideal solutions in which partial pressure of each component A and B is higher than that calculated from Raoult's law shows positive deviation, means a higher value is obtained, and that's why it's said as positive deviation from Raoult's law. Water and ethanol shows positive deviation because force of attraction between ethanol and water is less than that of ethanol and ethanol or water in water molecule. Therefore, vapor pressure is higher. For negative deviation from Raoult's law, the partial vapor pressure of component A is found to be less than the calculated from Raoult's law on addition of second component B, and when A is added to B, the partial vapor pressure of component B is found to be less than that calculated from Raoult's law. The total vapor pressure of the solution is less than that of ideal solution of same composition. Boiling point of such solution is relatively higher than the boiling point of A and B respectively. This type of deviation from ideal behavior is known as negative deviation from Raoult's law, and the example we can take as chloroform and acetone. They show negative deviation because force of attraction between chloroform and acetone are higher than that of chloroform and acetone molecule. Therefore, vapor pressure is lowered. Coming to 8th question, students, explain why a solution of chloroform and acetone shows negative deviation from Raoult's law. Now over here, the basic concept is the formation of hydrogen bonding, due to which escaping tendency of molecule decreases and vapor pressure of the solution decreases. Boiling point of the solution increases, hence such solutions show negative deviation from Raoult's law. Coming to 9th question, state how the vapor pressure of the solvent is affected when a non-volatile solute is dissolved in it. So when non-volatile solute is added, the escaping tendency of the solvent into vapor phase reduces because of some of the solute molecules occupy the position of solvent molecules on the liquid surface, and thus lowers down the vapor pressure of the solvent. And henceforth what happens is the vapor pressure of the solvent is affected. Coming to 10th question, we have to define mole fraction and Windhoff factor. So when we talk about mole fraction, the mole fraction is nothing but the fraction which is a part of the molecule which has to be taken up into consideration. So the fraction of a mole, that is a part of the mole which is given as Na upon Na plus Nb, is considered as the mole fraction, and the Windhoff factor is the ratio of experimental value of colligative properties to the theoretical value calculated on the basis of normal behavior of solute is known as Windhoff factor. Coming to 11th question, it's a numerical. A 5% solution by a mass of cane sugar in water has a freezing point of 271 Kelvin. Calculate the freezing point of 5% solution of glucose in water. The freezing point of pure water is 273.15 Kelvin. The molar mass of cane sugar is 342 grams per mole and the molar mass of glucose is 180 grams per mole. Now over here, WB is 5 grams given to us, WA is 95 grams given to us, MB is 342 which is given to us, and delta TF is 271 Kelvin and delta TF is 273.15 Kelvin. So when we calculate delta TF, that is delta not F minus TF, it becomes 273.15 minus 271, so that is 2.15 Kelvin. Delta TF is equal to Kf into WB upon MB into 1000 upon WA. Now over here 2.15 is the value of delta TF, so substituting all the values, 2.15 is equal to Kf into 5 upon 342 into 1000 upon 95. While in the case of glucose, that is delta TF is equal to KF into 5 upon 180 into 1000 upon 95. These are the two relations. Now, dividing equation 1 by equation 2, which we have taken in the last slide. So, there 2.15 upon delta TF is equal to 5 into 342 into 180 upon 5, or on simplification it becomes delta TF is equal to 2.15 into 342 upon 180 is equal to 735.3 upon 180, which is equal to 4.085, which was the desired answer for this numerical. Coming to 12th question, freezing point of 5% by mass solution of glucose in water, that is 273.15 minus 4.085, which is equal to 269.065 Kelvin. 100 grams of protein is dissolved in enough water to make 10 ml of solution. If this solution has a osmotic pressure of 13.3 mmHg at 25 degrees Celsius, what is the molar mass of protein? Where R given to us is 0.0821 liter atmosphere per mole per Kelvin, and 760 mm of Hg is 1 atmosphere. It is also provided to us. So over here, the formula which we will use is pi v is equal to nRT. Pi is 13.3 mmHg, that is 13.3 upon 760 atmosphere. So that way it is because 760 mmHg is 1 atmosphere. V given to us is 10 ml, that is 10 by 1000, so 0.01 liter. R given to us is 0.0821 liter atmosphere per mole per Kelvin, and temperature is 25 plus 273 converted into absolute temperature, so that becomes 298 Kelvin. Student, take care that this temperature is to be calculated and converted into absolute temperature, otherwise our relation will and answer will become wrong. WB is 100 grams, so again is to be converted, so 100 upon 1000, that is 0.1 gram. So milligram is to be converted into gram. Now the relation becomes 13.3 upon 760 into 0.01 is equal to WB upon MB into 0.0821 into 298. On simplification, 13.3 upon 760 into 0.01 is equal to 0.1 upon MB into 0.0821 into 298, or MB becomes equal to 0.1 into 0.0821 into 298 into 760 upon 13.3 into 0.01. On simplification, it becomes 1859.401 upon 0.133, which on simplification is 13,980.45 grams per mole, or 1.4 into 10 to the power 4 grams per mole. So this is basically the numerical part which we have considered and the questions which we have considered for solution. So student, all the best of luck to you. Revise these questions, write the questions with answers. First of all, note them, then practice them properly. Time is short, so it's very effective that you have a writing practice. Thanks a lot for patiently listening to this session, and all the best. Take care and be healthy and more prominent.